Welcome back, my friends, to the show that never ends. Sean here, Mountains Garage, still working on the 6-liter Turbo LS project. The first week, I really thought I was getting it done, and now it's kind of dragging out. Having to do another set of heads certainly slowed me down. But I can't step too far off the path of doing it to the best of my ability. So after we did the valve job on Sunday, the heads were still dirty. I came out yesterday afternoon, and in 3 hours, wire wheeled the heads, cleaned the gasket surfaces, chased all the threads, cleaned them again, ran them in the ultrasonic parts cleaner in every possible position you can think of, dried them off, sprayed them with carb cleaner, dried them off again, and when I went inside the house last night, I was ready to assemble the heads. Finally. I got a little carried away today, and I went ahead and assembled the driver's side head, and I got it sitting on the block with the gaskets over the studs with just one nut holding it on. Traditionally, I check the number one cylinder because it's easiest to know what top dead center is. That's how I check my piston to valve clearance. But again, I got carried away. This side's all assembled and bolted on. It would only take me a minute to pop the springs back off, but I just decided to check the other side. It all ends up the same. So let's go over the figuring I've been doing. Final assembly of the heads using my PAC 1218 valve springs. That's the part number, 1218. Their maximum lift that they will accommodate is 600. I should have written it up here, but we'll have to go with it. They recommend a 1.800 installed height. And after my valve job and my slightly thicker seat on my new valve seals, I'm at 1.800 exactly. This actually reads 1795, but I always check it with another device because I'm not sure I trust this entirely. It has a pretty coarse thread, and I'm at 1.800. So if I had 600 lift, it would be open at 1.200. It would bind when the springs touch and bad things happen at 1.140. So I have a 60,000 safety margin if I had 600 lift. I only have 585 thousandths lift. So all the same math, and I have a 75 thousandths safety margin. I am more than good. With valve springs, it's very important to run the least amount of spring possible. Now I know very little about valve springs. I know enough to do the math and assemble things the way I always have. I have a friend, Tom Vigu, 3V Performance in North Carolina. He spent, I don't know how many hours, working on a machine called the Spintron. And he knows things about valve springs that I'll never even understand. Because that machine electrically runs the top end of the motor. It can measure harmonics, and they can run some pretty serious lift with some very minimal valve springs that have great longevity. That's how these NASCAR cup motors and etc. go so many miles without blowing up. We've come a long way in valve spring technologies thanks to machines like the Spintron, and it trickles down to us. And like the Beehive spring is a nice spring for all the reasons stated, but I only know enough to do the math, and there's very smart people out there that can help you if you need it. They're called a Beehive spring because they taper at the top, and they kind of look like a beehive compared to a traditional valve spring that's straight. When I assembled the driver's head a few minutes ago, I lapped in the valves, and instead of like the experience with the 862 heads where when you first start lapping in a set of valves, it sounds really gritty. It takes a long time for it to get quiet. If you know what I'm talking about, you know what I'm talking about. Instantly, when I spun these valves with my drill, they went from gritty to quiet, and they made a perfect witness mark all the way around each one, halfway down the ground part. I mean, it's perfect. And everything worked out for the best, and my installed height ended up okay. I did cut, I didn't film it, but on the other end of the valve grinding machine, I cut 1.5 thousandths off of each stem. So it shouldn't affect my preload, and it should be good to go. So I'm installing a version of the Sloppy Stage 2 camshaft, the world's most popular LS drop-in camshaft. I can guarantee 90 some odd % of the people never check piston to valve clearance and don't have any trouble. I have all these tools. As I said before, I'm going to go through the steps to the best of my ability. I just won't sleep at night otherwise. So I put my check-in springs on this head, and I have the head installed with no head gasket. I like to make sure I have clearance without it. And once I add the cylinder head gasket back in, I have that much more clearance to go by. If I checked it and it was really tight or questionable, then I'd have to add the thickness of the head gasket into my safety margin, which most people say 60 thousandths is about the minimum you'd want, and 100 is pretty normal. So somewhere in that range, if I was close, which I'm not, I just checked it, but if I was, I would add the gasket and redo this whole thing again. I don't have a solid lifter for an LS motor to check piston to valve clearance with, but I effectively created one when I went ahead and soaked the lifters in oil for about a week before I installed them. A lot of people say you shouldn't do that because it makes it hard to check lifter preload. But in this case, it works out well because that lifter is very solid and it easily compresses the checking spring. Of course, the LS has a non-adjustable valve train, so when I'm checking piston to valve clearance, I just set this to 0. When it starts to compress the spring, I'm going to call that 0, and I go ahead and check piston to valve clearance using that method. When it comes to actual piston to valve clearance, I simplify it as much as humanly possible. The only time these are going to interfere with the piston is when they're moving. So I rotate the engine slowly with my check-in springs, and as soon as it starts to crack, either one, exhaust or intake, it's the intake, but it goes that direction. As soon as they start to move, I just start seeing how much clearance I have between that and the piston. As the piston chases the exhaust valve up and the intake valve starts to chase the piston down, I just run it through its travel. You can go backwards and forwards if you're unsure what you're measuring, and see what's going on. It's more hands-on. There's a lot of other methods you can use. Clay, there's at least 10 ways to do it. I'm not sure how many, but this is what I do, and it works. I like to feel what's going on, and if it's questionable, then I will actually measure it or come up with different methods and double check myself. But in this case, again, I'm installing the world's most popular turbo LS cam and the world's most popular motor at this point in time, and it's got plenty of clearance. So in my head, I'm satisfied that I checked it. So now I'm going to put the head gasket on this head, set it back on with the check-in springs, and I'll show you what I do for lifter preload checking. Well, I thought about it overnight, and before I went too far off the beaten path with my crazy methods of checking lifter preload, I decided just to check it the traditional way. So I went ahead and assembled the other cylinder head with the new springs and installed them both on the block for the final time with the eBay studs. But I do treat the cheap studs to the good ARP assembly lube. In the ARP instructions, when they use their own lube, the torque setting is actually lower. So taking all that into account, and there's already volumes written on the internet about different torque settings and which is better and reusing torque to yield bolts. You can research that for yourself. But some smart people have actually tested how much it takes to break these. And knowing what I know, I lube both sides of the washer, and I torque them to 65 on the big ones and 25 on the small ones across the top. And I do that incrementally. I sneak up on it. And after about 35 pounds of sneaking up on it, the washers stop moving. There's no spooky feelings. They torque right up nice. No complaints whatsoever. They're $50 studs and they work pretty well. My only warning, and it has nothing to do with the studs, other than they have a nut and a washer, is the inside ones. I go ahead and put all the fasteners on both heads all lubed up, because when you're setting them in the hole, I use needle nose and set everything in there. If you drop that, it's going down into the abyss and you got to go digging for it. So I would hate to have a head bolted on and have to take it off to go looking for it. So I just get all the hardware in place and then I start my torquing procedure. The beauty of an LS and a flaw is there's only 10 big head bolts to torque down. It'd be better if each cylinder had 6 bolts instead of 4, or some combination thereof, but in this case you're only going 10 and then increasing the torque, and then 10. It's pretty simple. Working in a crisscross, big circle, working toward the outside. That's all I got to say about that. It's a cheap motor with cheap studs. Nothing scary. Everything went together just fine. The Elgin push rods that I got in the lifter kit, they're made in USA. They're good quality. They are 75 thousandths wall. They are the ball type, not my favorite. I'd prefer if it was like these. This is my adjustable length push rod. But at only 585 thousandths lift, that's not crazy compared to, 8 or 900 that I'm used to on a big block Chevy. So I think in this application, these will be just fine. If they're not, well, I'll be the first to know. On the Elgin site, they're listed as 7,393, and that's exactly what they measure. Online, these were sold as 7.400 length push rods. A lot of people round up, so don't assume that you have a 7.400 push rod unless it's printed right on it by Crane or somebody like that makes it. So lift the preload. This is a non-adjustable valve train, so when I tighten that bolt down tight to the head, I'm going to depress the plunger in the push rod a certain amount. I'm shooting for around 50 thousandths. Cam manufacturers will tell you anywhere from 20 to 100, depending on how much oil they think the lifter should contain while it's running, depending on RPM range, whatever. We're shooting personally today for somewhere in the 50 thousandths range. If I just went ahead and bolted that in, I'd have no way of knowing how far the plunger went down in the push rod. So I'm going to start with the adjustable length push rod about 50 thousandths too short. And if I can bolt the rocker arm up without it getting tight before the bolt's tight, which means I'm depressing the lifter plunger, then I'll be able to keep adjusting this until this goes down at 0, let's call it. And then the difference between this and this will be my plunger preload. If I was going to order push rods for the ideal pie in the sky setup that I wanted, I would do the same procedure, just get this in. So when I tighten that, it's not depressing the plunger in the push rod. And then I would just add how much preload I wanted, 50, 60 thousandths onto the length. So in this case, I have a push rod that I want to use. And if it falls in a range anywhere around 50 thousandths, it's going in the motor. You need to be on the base circle of the camshaft to measure the push rod length and preload. So just like you would with an adjustable valve train, I rotated the engine to the intake, was fully open and started to close. That puts the exhaust in the checking position. And then I manipulated the push rod length until I'm just at, if I back it off, I got play. That's tight. I got nothing. I can actually feel the preload, but I'm at 0. I'm not pushing at all with that tight, but everything's tight. There's no lash. Now I'm going to measure the length of the push rod and compare it to the 1.5. Final results, I'm at 7,330. A little quick math, that's 63 thousandths preload. I'll take it. A little more than I was ideally looking for, but it's a really big margin. So that's in the range. It'll fly. She's going together. Forgive me during that last segment when I kept saying the plunger in the push rod. It's in the lifter. I have push rod on the brain because I was talking about push rods. I made a mistake about 5 times. So the last thing I accomplished for this video, I blew out all 16 push rods with brake clean and then air because I don't trust that they're clean even though they're new. And I lubed the ball on the downside and shoved them all in. That's going to do it today. I got about a 1-minute montage I'm going to stick at the end. It was a beautiful day today. 56 years ago today, just before breakfast, I was born. It's my birthday and it shot to 50 degrees. Yesterday morning I was plowing snow. Today I'm outside playing and stuff. And I was moving vehicles around, doing some fun stuff. So if you want to watch it, go ahead. It's about a minute. This is me saying goodbye, and I'll catch you next time. top of the snowbank. Let's fire up the old Dodge. Fuel pump. Just like that. I'm going to drive up to the mailbox. We'll see if the engine starts knocking. If it is, I'll bring you back. Piston slap. Yep, here. Goes away in about 45 seconds. The Suburban's only two-wheel drive, but I think she'll come out of there. Let's see if it runs. Yeah, Suburban was a little bit frozen in, but we got her out. Got some cleaning to do. Little cleanup. I was cleaning off my best friend who gives me a lift every now and then. I broke the pallet.